Hey everyone. Today we are going to do an introduction into series. We're not going to dive very heavy into series, but we are going to introduce them, kind of see what they look like and some basic things that we can do with them. After this lesson, we are going to start doing more of the tests and things of that nature. Okay, so introduction to series. We have example 1. Consider the following series. Do they add up to a finite value? So let's look at this first example. We have 3 over 10 plus 3 over 100 plus 3 over 1,000 plus 3 over 10,000 plus 3 over 100,000, and we keep going on and on. So in fraction form, it's a little hard to see, so let's look at these in decimal. So I have 3 divided by 10, and this is 0.3 plus 3 divided by 100. This is 0.03 plus 3 divided by 1,000 is 0.003, and you can kind of see the pattern. So plus 0.00003 plus 0.00003. And as you can see, we just keep adding more zeros, a zero every time we move across. And so if I add all these up, this is 0.33333, and it's just going to keep repeating. But we know what that decimal is. We know that this is actually 1/3. So by summing these together, we are breaking 1/3 into an infinite number of subdivisions. And so in this particular case, we're breaking 1/3 into an infinite number of subdivisions. So yes, our sum adds up to a finite number. Okay, so most of the time when we talk about adding up numbers, most time when I start a class off, especially if it's in person, when I ask, hey guys, can I add an infinite number of numbers together and get a finite value? Most people say no. And here's an example of when we can. So we're adding a finite or an infinite number of numbers together, and I'm getting a finite number. So 0.3 plus 0.03 plus 0.003 and on and on and on and on forever, and they just add up to 1/3. What this does not mean, it does not mean 1/3 is infinitely large. So it's not infinity, it's just 1/3. Okay, so let's look at B here. We have 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2. So let's look at these, summing them together. I'm going to call this partial sums. So I'm just going to add the first one together, and I get 1/2. S2, the sum of the first two, I'm going to add those together, and I get 1/2 plus 1/2. That equals 1. S3, I'm going to add the first three. 1/2 plus 1/2 plus 1/2 equals 1.5. And as you see, the more I add these together, so S4 is going to be 2, S5 is going to be 2.5. And so if I keep going, Sn is going to be 1/2 to the n. I'm just adding 1/2 n times. Well, as our n keeps getting larger and larger, so we're going to add an infinite number of these, then our sum, our 1/2 n, goes to infinity. So this particular one does not add to a finite number. When you add all these up, they really just keep going and going and getting bigger and bigger and bigger. Okay. We would actually, using our verbiage before, say this sum diverges. All right. So example 1 continued. We have considered the following series. Are they convergent or divergent? C says the summation of n equals 1 to infinity of 3 divided by n times n plus 1. Okay, so we have not really seen this notation before. And it says hint try partial fractions. We'll talk about that in a second. Okay, so first of all, this piece right here, this is a summation symbol. And we have n equals 1 to infinity. That means we're going to plug in 1 into the 3 divided by n times n plus 1, and then we're going to plug in 2. We're going to plug in 3, 4, 5, 6. We're going to keep going. We're going to add them together. So let's write that out. Let's write this out to the first, 5 terms. So I have 3 divided by 3 times 3 plus 1, close parenthesis, close parenthesis. Oh, sorry. I don't know why I'm plugging in 3. 3 divided by 1 times 1 plus 1. So I'm going to plug in 1 in for n. Change this to a fraction. And I get 3/2. And then I'm going to add in, and then I've done for n equals 1. Now I need to go to n equals 2. So we have 3 divided by 2 times 2 plus 1. And we get 1/2. And then I'm going to do it for 3. So 3 divided by 3 times 3 plus 1, 0.25, which is 1/4. So plus 1/4. I'm going to put in 4. 4 times 4 plus 1. I get 3/20. And then I'm going to plug in 5. So 3 divided by 5 times 5 plus 1. Oops. I get 1/10. Okay. And then we would just keep adding and going and going and going. So this particular one down here is when n equals 1, n equal 2, n equal 3, n equal 4, n equal 5. And we want to go, so just like the integral, this is where we start, this is where we stop. So we want to keep going to n equal, and I'm going to put this in quotations, infinity. We want to just keep going and going and going and adding all them up. And we want to know, does that converge or diverge? Well, this isn't very helpful. So in the before ones, we had 0.3 times 0.03. We could kind of see where it was going and get a sense of the number. Here, if we add 1/3 plus a half, we get 2 plus 1/4 plus 3/20. We're not getting a very clear pattern here. So doing what we did on that first page, just kind of adding them up and seeing what in the world's going on, does not help. We have a hint here that says try partial fractions. Okay, so trying partial fractions, that means I want to rewrite this 3/n times n plus 1 as a partial fraction. So I have 3/n times n plus 1. And I want to write this as a/n plus b/n plus 1. Now, if I multiply both sides by that n times n plus 1, what we get is 3 equals a times n plus 1 plus b times n. And remember, we want to solve for what a and b are. So we have 3 equals an plus a plus bn. So 3 equals a plus b, n plus a. Now, really, we have a 0n plus 3 here. It's just, we don't see it. So what I get is a plus b equals 0 and a equals 3. Well, if a plus b equals 0, but I know a is 3, that means b has to be -3. Which gives me that 3/n times n plus 1 is 3/n plus -3/n plus 1. So I'm going to try and work with that series. So we have the summation of 3/n times n plus 1, n equaling 1 to infinity, is equal to the summation of n equal 1 to infinity of 3/n plus -3/n plus 1. Now, I want to expand this. Okay, so I'm going to plug in 1. And when I do that, we get 3 over 1 plus negative 3 over 1 plus 1 is 2. Okay, so this is n equals 1. Now I'm going to plug in 2, and now I get plus 3 over 2 plus negative 3 over 2 plus 1, which is 3. This is when my n is 2. Now let's plug in 3. If I plug in 3, I get 3 over 3 plus negative 3 over 3 plus 1 is 4. This is n is 3. I'll do one more. And if I plug in 4, I get plus 3 over 4 plus negative 3 over 5. So, and we want to just keep going and doing this an infinite number of times. But notice negative 3 over 2 plus 3 over 2. That cancels out. Negative 3 over 3 plus 3 over 3. That cancels each other out. Negative 3 over 4 plus 3 over 4. That cancels each other out. So it keeps going. And so we get that this sum is 3. Since all the terms cancel after 3. Okay, so this method that we just did does not always work. It's not always helpful. What we did in A and B, not always helpful. So we really need to learn and develop a variety of skills in order to work with these. Okay. So I want to go ahead and try D. You don't have to use partial fractions. That hint was not supposed to be there. Actually, C should have been where D was. Okay, but go ahead and try D. The summation of n equal 1 to infinity of negative 1 to the n. Okay, welcome back. We can go ahead and try what we did in A, B, and C, kind of just summing them as they go along, and see if we get a pattern from this. So S1 is when we sum the first term, and if we have a 1 up here, S1 is negative 1. You know what? That is not helpful. Let me expand this out. So what we get is negative 1 plus 1. So if I plug in 2, I get negative 1 squared. If I plug in 3, I get negative 1. Plug in 4, I get 1. And so notice the pattern. So we get negative 1 plus 1, negative 1 plus 1. Which is nice. It alternates like this. But let's see what happens when we start adding them together. So we have S1 where we sum the first term, and we get negative 1. If I add the first 2 terms, I get 0. First 3 terms, I get negative 1. 4 terms, I get 0. So notice, as n goes to infinity of my sums, Sn does not approach anything. It's oscillating between -1 and +1, -1 and +1. So Sn alternates between -1 and 0. And so this diverges. All right. So on to example 2. We have considered the following series. Are they convergent or divergent? And before we have some of these rules, and they work just like integrals. So remember back when we were doing volumes and areas, we used the summation symbol really loosely. And, if we had two series, if they sum together, they can be broken up or added together. A constant can move across them. So very similar rules as integrals work for summations. That's if they are convergent. So divergence test, the nth term test, this is our first test that we are learning. This is an important one. It says, suppose we have an infinite series, the summation of an. If the limit as n goes to infinity of an does not equal 0, then an diverges. What people always ask is, well, Katie, what if the limit does go to 0? I don't know. We don't know if it converges. We don't know if it diverges. We have to do more testing. However, we know if it does not equal 0, it diverges. So let's look at that here. If we take the limit as n goes to infinity, and what we're going to do is we're just going to look at this series here. And this is n squared over n squared minus 4. Right now, if I plug this infinity in, what I get is infinity over infinity, which does not help. So we are going to use L'Hopital's. Remember how I said L'Hopital's would come in handy later? So then we get the limit as n goes to infinity. We're going to take the derivative of the top, which is 2n, the derivative of the bottom, which is 2n. And if I cancel this, then I get the limit as n goes to infinity. These cancel. It gets 1. So this equals 1. So what this test tells me is that the limit as n goes to infinity of n squared over n squared minus 4, this does not equal 0. Therefore, the summation of n squared over n squared minus 4 diverges. So we know without writing out all the sums, without doing all these different things, that this simply diverges. This is the test that comes in handy. This is the one that I often first go to. However, if they both go to 0, then it's not very helpful. Speaking of which, let's look at example 3. So it says, using your calculator, compare the following series. What do you notice? The first thing I want to do is show you the limit as n goes to infinity of 3 over n squared. This is 0. Also, the limit as n goes to infinity of 3 over n is also 0. Most people like to say, because of this test, that they converge. That is not what this test says. This test says if it doesn't go to 0, then it diverges. So let's look at these. We can do this on our calculators. I'm going to look at, what I'm going to do is I'm going to look at the limit as t goes to infinity of the summation of n equal 1 to t of 3 over t squared. So I just, not t squared, n squared. Essentially, I want that top number to go to infinity, and I want to see what does the sum doing. So let's just try it. We're going to hit the math key, which is below the green alpha key. We're going to scroll down. And it says summation. We're going to use x's. It's okay. So I'm going to do x equals 1. And I'm going to start off at 100 of 3 over x squared. And I'm going to erase some of this to make it a little bit easier to read. So we're going to go to 100. This is 4.9. And some of these might freeze your calculator. It's okay, just give it a little time to think. And then, what if I go to 1,000? So we take the summation of n equaling 1 to 1,000 of 3 over n squared. This equals 4.93. Then, let's look at the summation of n equaling 1. Let's do 10,000. And that's going to freeze our calculator enough. So this is going to be the last one I'm going to do. So 10,000. Okay, I'm going to go ahead and give it away while my calculator's thinking. This is 4.93. So what is happening is as this top number is getting closer and closer to infinity, our summation is getting closer and closer to 4.93. So the summation of n equaling 1 to infinity 3 over n squared is approximately 4.93. It does not mean it is 4.93. We have to do other processes to actually calculate the sum. We can't just get closer and closer to infinity. As you see, our calculator freezes. But it's going to get closer and closer to 4.93. There it goes. Okay. So that was nice. So let's look at the other one. So the limit also equaled 0, like it did on the first one, and the first one converged. But let's look at the second one. If I do math 9, oops, not math 9. That's fine. Math 0. Let's go x equals 1. Let's just say 100. 3 divided by x. We get 15. Okay, so the summation of n equal 1 to 100 of 3 over n. This is 15.56. So let's go ahead and look at what happens when we go to 1,000. So n equal 1 to 1,000. of 3 over n. Oh, we get 22.46. Now, let's go to 10,000. Again, your calculator is going to freeze. Just let it sit there. It's okay. It's just calculating. So the summation of n equaling 1 to 10,000 of 3 over n, and I'm going to go ahead and give it away, is 29.36. Notice this is not approaching a number. These are getting larger and larger. If my calculator had more memory to it or more RAM to it, or however that works, this we could calculate bigger and bigger numbers, and when it would go off to infinity. So the summation of n equaling 1 to 1,000 of 3 over n really approaches infinity. So this diverges. My calculator's still thinking. So notice how we can use this divergence test, and sometimes it's very helpful. Like in this example 2, we took the limit of n squared divided by n squared minus 4. We found the limit equals 1. And because it's not 0, we automatically knew it was divergent. It diverges. We were done. We didn't have to do anything else. However, on example 3, you can see that we have two series that converge when we do the divergence test, or not converge. We don't have any information about them when we do the divergence test, so we have to do a little bit more work. So this method of looking at larger and larger numbers doesn't always work, especially because you don't have the computing power. So in our future lessons, we're going to talk about different tests, the series tests that we can use in order to find out if a series is convergent or divergent. All right, guys, if you have any questions, please feel free to let me know. And have a wonderful day.